let's use what we know about arc functions or inverse trig functions to try to evaluate these functions at certain values. So in this case we have arc sine of 0. So in the case of arc sine of 0, what you want to do is you want to say, okay, I know that this relationship holds, that y is arc sine of x when sine of y equals x, again under a restricted domain. And the domain, the range of values that come out of here are from negative pi over 2 to pi over 2. So since I know that, I need to make sure that whatever I do to solve here, that I get the right value. And then arc sine, the x value has to be, or anyway, so if I want to evaluate this, I need to rewrite this in this form. So if I know that, for instance, that arc sine of 0 is some value y, I'm not sure what, then I can rewrite that and say, okay, I know that sine of y has to be 0. So what I have to do is I have to think, okay, for what value of y, sine of what is equal to 0? And what we find in this case is sine of 0 is equal to 0. And that's how we would solve that type of problem. And that's a fairly trivial one. But in the case of arc tangent of 1, we do the same process, but we have to be a little more clever because we don't just end up with 0. So we say y is arctangent of x in the case that tangent of y is equal to x. Okay? And then we know that the outputs here are going to be somewhere, y is going to be between negative pi over 2 and positive pi over 2. Okay, so then what we're going to do is we're going to use the same method. We're going to rearrange this. We're going to say, okay, y is arc tangent of 1. That tells me that tangent of y equals 1. Okay, and you may say to yourself, I don't remember when tangent of y is equal to 1. Okay, that's reasonable. I understand that. But if you didn't know that, what you would say is, okay, well, I know that tangent is sine of y over cosine of y. So if I multiply both sides by cosine, I get the case where sine and cosine are the same value. So if you think then to kind of your unit circle values, you can recall that sine and cosine evaluate the same at either pi over 4 or 5 pi over 4. But in this case, we have to restrict our outputs to the first and fourth quadrant. So that tells me that y is pi over 4. And that, pretty much any other problems like that work similarly. You're just using properties of inverses to evaluate these functions.